go ahead and take a look at a classic example in binomial random variables. And the classic example is flipping a coin, right? The outcome of flipping a coin. So if we let the variable be, right, the number of times the coin lands on heads, right? So that's what we're trying to measure. This is a binary scenario since the trial, when we flip the coin. In this case, we're going to flip it 10 times. So it's also fixed, right? That you end up with a heads, that's success. If you get a tails, we consider that failure. So you have those two outcomes. Independent, identical, where we're going to assume the coin is fair and that each flip, right, that one flip does not affect the outcome of another. So that's independent. And that the probability doesn't change. It's always a half that it lands on heads. Fixed, n, your bin, your binary is 10. All three requirements are met, and this would be considered a binary random variable. Now, when we have a binary random variable, and we'll look at this outcomes, right? What's the probability of getting 3 heads, right, out of 10? Or what's the probability of getting 6 heads out of 10? We can answer a question like that. We need to consider certain variables when we're actually going to do the calculations. You will see here, we can do this by hand using this formula here. Now, some of you may have experience in previous math classes, and some maybe none have seen this. These are called combinations. N choose x. This is p to the power of x. So you may not, you may see this and say, I don't like it. That's okay. We have the ArtistStat, our software in the class we've been using, can calculate a binomial distribution to find probabilities. And you have that in your homework. You'll see an example. I'll complete one here also, okay, as we think about it. So in example 1, we see that your n is 10. That's one of the key variables, the number of trials. P is considered the probability of success. And so we're going to see this P and Q throughout the rest of the semester or the course. So keep in mind that, again, this is the probability of the outcome we're looking for. Q is the probability of failure. And we use the complement rule to calculate that 1 minus P, right? 100% minus the probability of success gives you the probability of failure. So keep that in mind. Some people always forget or memorize. Again, it's the complement. There's only 2 outcomes, okay, as we have that. In this case, they're both 50%. And so that's what how we would do that. Now, we need to know these NPs and Qs so that if you're going to use a hand calculator, scientific, you would need the formula. If you're going to use the ArtistStat, you need those also. You would enter in your X value, the probability of success, your N, right? And so you would end up with that. Here's the first example that we have, and I'll show you how this gets entered, but take a look at the situation. When an adult is randomly selected, there's an 85% probability that the person has a Facebook account, okay? So we know 85% of people have Facebook accounts, or at least that's old data. When we select 50 random adults, so the probability, right? Now we're going to consider that. What's the probability after selecting 50 random adults, that's the key random, that 42 have a Facebook account? Well, we would have to do N is 50, P is 85, Q is 15, and then you either use this or we use the ArtistStat to do this and to get these answers here that you see. What's the probability that 42 have a Facebook account? What's the probability that no more than 42? So that's X is less than 42. And then at least 42 means 42 or more. So how would we calculate that? Again, it's too complex to do by hand, like doing the multiplication rule. It may be easier to use this formula, or we use the ArtistStat. So we're at the ArtistStat now. We're going to go to the web apps. You have all the links for that. And so what we're going to be looking for is the binomial distribution. There it is. And so the binomial distribution opens up. We hit find probabilities. In this case, on that Facebook problem, we know we had 50 adults that we were going to be asking, randomly selected them. We know that 85% of them have a Facebook account. Type of probability, in the first case, we wanted to know if it was 42. What's the probability if that 42 people have a Facebook account out of the 50, and then we get a 14% chance. What I really appreciate about the ArtistStat is it shows you the distribution and gives you the answers to other X values also if you kind of browse through it. But the one we're interested in is the 42 out of the 50. Remember, 42 out of 50 is 84%. That's why students get confused. I'm asking, what's the probability that if you ask 50 people if you have a Facebook account, what's the probability that 42 of them would say yes, they do, given that we know 85% of the population has Facebook accounts. So out of those 50, we get 42 say yes 14% of the time, 41, 12%. So you see that distribution. Now, the follow-up questions on our sheets were, what is it? No more than 42. So then you use the less than or equal to 42, or then you get that 48% answer here. And then notice it highlights the left part of the left tail, and then at least 42, that's the upper tail, and you see that it highlights that upper tail, and you get the 66% there. So that's how you're going to use, and it's okay to use the binomial calculator to calculate binomial probabilities.